What's up, rock stars? Video 14 coming at you, independent versus dependent probability. Let's get started. What's an independent event? When two events are said to be independent of each other, what this means is that the probability that one event occurs in no way affects the probability of the other event occurring. An example of two independent events is as follows. Say you rolled a die and you flipped a coin. The probability of getting any number face on the die in no way influences the probability of getting a heads or a tails on the coin. This really has to do with the gambler's fallacy. The gambler's fallacy is this idea that you think two things are related when in reality they're not. So for example, let's say you flip a heads, a heads, a heads, a heads, a heads. What's the probability that you get a tails here? Well, you might think, hey, we're due for a tails, right? Because we had a bunch of heads. That's false. These are independent events, meaning we don't even care what happened previously. What we care about is what's the probability of flipping a coin and getting a heads or a tails. Well, it's always 1/2. It doesn't matter what happened before. It does not impact what happens here. Same thing with slot machines. You might think, oh, this slot machine hasn't had a winner in a long time, so it's due to pay out. Actually, no, that's not the case. Every time you pull down the handle on the slots, you have a 1 in 10,000 chance or something like that of winning, and it doesn't depend on what happened previously. It's the same thing every single time. Okay, what about dependent events? When two events are said to be dependent, the probability of one event occurring influences the likelihood of the other event. So for example, let's say you have a bag, it's not a cat, it's a bag, with a black marble in it, and you've got a red marble, maybe 2 red marbles, and then maybe you have a purple marble. All right, the question is, if you pull out a marble, you're going to do 2 marble pull. And you pull one out, so the first pull, let's say you pull out the black. The second pull, is the second pull what you get from pulling out of that bag? Does it depend on what happened here? Does the probability change? Yes, it absolutely does, because now you have a 0 out of 3 chance of getting a black, and you have a 2 out of 3 chance of getting a red and a 1 out of 3 chance of getting a purple. So not only do you lower the number of actual marbles in the bag, which impacts the probability, but you also can no longer get a black because you pulled out 1 to begin with. So these are considered dependent events because the probability of one event occurring, pulling this black out, does influence the likelihood of another event happening. Independent events, whatever happens in one event has absolutely nothing to do with what will happen next. First of all, because the two events are unrelated. An example might be pulling a card and then flipping a coin. Those two things are unrelated. Okay? You repeat an event with an item whose number will not change. For example, you might be spinning a spinner or rolling a dice or flipping a coin. This is a different situation. This is one to take note of. You repeat the same activity, but you replace the item that was removed. So let's kind of go back to our bag here. We had 1 black, 2 reds, and a purple. And this is talking about replacing. So let's say that on your first pull, you got a black. But then you replace it, meaning that's a fancy way of saying you put it back in. You put it back in. So now the second pull, is that influenced at all by what you pulled out first? Absolutely not, because you put that marble back into the bag. So these would be independent. Always, if you replace something back into the bag or back into the drawer or back into the box or whatever, that's going to be independent because you've put it back in. All right, pause this video and go through each one and try to figure out, is it independent or dependent? And put an I next to the ones that are independent and D that are dependent. All right, you're back. So I said that the first one was independent. Those two things do not influence each other at all. Now, the second one is dependent because a student picks a raffle ticket from a box and then picks a second raffle ticket, and they do not replace the raffle back into the bag. Okay, this next one is about pulling out checkers and then replacing it, putting it back in the bag, and then trying to pull out another thing. Because you're replacing it, it's going to be independent. All right, rolling a 6 on the first roll and then rolling an odd number on the second. It does not matter what you roll on the first one. It does not impact at all your second roll, so that's going to be independent as well. All right, next one. Go ahead and pause again and see if you can get this right. Okay, welcome back. All right, a box contains a penny, a nickel, and a dime. Find the probability of choosing a dime first, and then without replacing the dime, choosing a penny. That's dependent because you did not replace the dime. It's out of the bag. It's impacting the probability of the next. A boy chooses a sock from a drawer and then chooses a second sock without replacing it. That's D. I'm going to skip this one for a second. We'll go back to it. The last one here is also dependent probability because once you've picked one person out, you can't pick that person again, and you've got fewer people to choose from. So that's definitely dependent probability. This next one here says, if he randomly chooses 2 coins, and in theory, that is at the same time. Now, I have students oftentimes do a bet on this one in class. I say, if you're picking 2 coins at the same time, is that independent or dependent? Well, here's how I can influence you. Let's say we have a bag with 1 black, 2 red, and 1 purple. Okay, and I reach my hand into that bag and I put 2 marbles in my hand. All right, now don't make fun of my drawing here. So I take my hand and I've got a hand, that's my hand, and I'm grabbing those 2. Is it possible at all, if I've got a black one on the right side of my hand, to have another black one on the left side of my hand? No, it's impossible. So even though you're picking these at the same time, if I have a black one right here, then it's impossible for me to have a black one on the other side of my hand. So actually this is dependent probability because what you have on one side of your hand actually impacts what you have on the other side of your hand. So this is going to be dependent probability. Maybe something to memorize, that picking some things at the same time is the same thing as picking one out, dropping it down, and then picking another one without replacing it. All right, that's it for independent and dependent probability introduction. Next video will be on calculating independent probability. Lots of fun.